All right, today we are going to take a step back and review things that I've already posted the answer keys to, but I want to make sure we understand them. So we are looking at this Blair County Festival problem, and you should have already read through it. You should have the information, and I like to underline or highlight normally when I'm teaching this. So we have the 2,000 total tickets. We have a cost in here. We have no more than 1,500 daylight rides. Again, there's a cost. No more than 100,000 of the moonlight rides, and they've also pre-sold some tickets. So here it is, write and graph a system of inequalities to represent the number of daylight rides and moonlight rides. So right there is my definition of my variable, the amount, the number of daylight rides, the number of moonlight rides. So number of daylight is X, number of moonlight is Y. If you flipped the X and Y, that's fine as long as your equations are flipped properly. So the first thing they told me was no more than overall 2,000 tickets. So this is nothing new. The tickets from daylight, the tickets from here, less than or equal to 2,000. So, or if we said we needed to sell exactly 2,000, we would say equal to 2,000. But this is an inequality, so less than or equal to. Now this is what's a little different. We worked on this in a prior packet about backpacks, briefcases, calories, and calculators. So we worked on a couple problems that look like this. It says right here, no more than 1,500 daylight rides. Okay, so the number of daylight rides is X, and we're comparing it to 1,500. There's no multiplication here, there's no addition. It's just the number of tickets being sold, no more than 1,500. Then we have no more than 1,000 of the moonlit rides. So we're comparing our number of moonlit rides, Y, and that's less than or equal to 1,000 also. So this is going to be our vertical line. X is less than or equal to 1,500 is an undefined slope with a vertical line at 1,500. And this is going to be our horizontal line at 1,000, a slope of 0. Now you always need your minimums, your implied constraints or implicit constraints. It doesn't remind you of that, but it does say 5 inequalities. So here are the 3 totals we had. These were maximums. We need minimums. So I need you to remember that. We need minimums. So if there was no minimum, 0 is the smallest number I can have. I cannot have negative tickets. But they did pre-sell 400 moonlight rides. So we know that the number of moonlight rides is going to start at 400 or be greater than that. And we're capped off here at 1,000. So you need a minimum. Again, if they don't give you a minimum, it's implied that you can't have negative items. They did give us a minimum because they were pre-sold, pre-ordered, anything like that, pre-packaged, ready to go out. So those are my inequalities. Notice that we have these 2 extra pieces of information, and those seem like I just threw them in there to distract you, and I did not. The next section we would typically do is section 3-4 on linear programming. And this would be our objective, or our goal would be to maximize revenue, which is money coming in. And so for that, we'd write an inequality, or we'd write an objective function like 7x plus 10y is equal to the money coming in. And then we would try to find answers that maximize that. So this is not being used as a constraint because in this problem, there is no limit. So if they had said something in the problem like no more than so much money can be brought in, or they said, if they said something like no, they need to make at least $10,000. Now I'm making that up, so I don't know if it works. If they said they need to make at least $10,000, then we would have had an inequality of 7x plus 10y is greater than or equal to 10,000. That's different. $7 times every ticket, money coming in from daylight, money coming in from moonlight. They would need 10,000 or more dollars. But there is no restriction on money, on revenue, on ticket sales. So we don't have an equation for this, okay? The other thing that'd be used for is, like I said, an objective function. So this extra information, it doesn't pair up with anything. Now, if you come down, you can count how you wanted. I found that counting by 200s works, so 200, 400, 600, and I like to try to use the same interval on each axis if possible. So I counted by 200s on each, so I could use slope, rise over run, but I chose just to use my x and y intercept. And so we put the 0 in, and I get 2,000, 0. So that's my point on the x-axis. Put the 0 in, I get y is 2,000. Both of them are less than, so we shade everything below this negative slope line. All right, coming back to my x is less than or equal to 1,500. There's that vertical line right here in the middle at 1,500. And less than would shade coming this way. So it cuts off this little corner here. Then we have the other x is greater than or equal to 0. Even though that's on the axis, look at your graph. Do you have that line there? So even though it's on the axis, you need to show and make sure we can see that you did graph x is greater than or equal to 0. Shading would stay here in the first quadrant. All right, your horizontal line at 1,000 caps it off. So we're losing all of that up here. We're cutting it off. And then your other horizontal line is at 400, and that's a little different. So that's why we lose all of this area down here, because we've already sold 400 tickets. So this is my shaded region. Notice there's a little corner cut off here. Okay. Some people are bothered by the fact that 1,500 and 1,000 add up to 2,500, and they're like, well, wait a minute, 2,500 is more than 2,000. But if you take a minute and think about it, if I bought 1,500 or sold 1,500 daylight rides, I can only sell 500 of these because this would cut it off. So this right here, this coming down, this one for the 2,000 is what cuts off the maximum of each of these together. Because right here is at 1,500, 1,000. And I can't sell that many because we're cut off right here. All right, now the last part is points. So you're going to be doing one like this for accuracy, one like this on a test. And so it says find and label find and label 2 possible solutions based on your graph. So I don't need to know that it's this many tickets or more because we are cut off, but I'm going to pick something in my graph like 1,200, 600. But I'm not just going to write it as an ordered pair. I'm going to write 1,200 daylight rides or daylight tickets and 600 moonlight tickets. So you should have 2 sets of ordered pairs. So there's one answer, and then I can pick something else. Maybe I pick 1,000 and 800. So again, 1,000 daylight rides or tickets. And I don't remember what I said, 1,000 and 800. Now, if I'm picking something closer to my line or I'm not really sure, the next thing I'd want to do that was required in another worksheet is take my answers and make sure they meet those stipulations. Both of these are well under 2,000. They both meet the stipulations for X and for Y in both cases. All right, the next problem we had in our packet was the All-American Cafe. Very, very similar, okay? So we're not changing it up much, but we have no more than 2,500 entrees, and they're serving 2 different things for the entrees. Hamburgers at this cost, hot dogs at this cost. A total of 1,000 burgers and 2,000 hot dogs, and we're writing a system to represent the possible number of hamburgers and hot dogs. Okay, so I've got my variables, amounts of, number of. Make sure it's not just X is hamburgers. It's not the cost. I know the cost, right? I don't know the total quantity. For me to find the cost, I'd have to know the total quantity, and I can find the overall price. So the quantity is what we're looking for. So again, no more than 2,500. So together, hamburgers and number of hot dogs, less than or equal to 2,500. They're capping off their hamburger sales at 1,000. That's how many they have to sell. And they're capping this off at 2,000. So again, together that's 3,000, but we can't sell that many. Okay, so if I sell 1,000 hamburgers, I can only sell 1,000 of these hot dogs, or sorry, 1,500 hot dogs. If I was trying to maximize my money being brought in, I would sell as many hamburgers as I could because I get more money in. That doesn't mean that it's a higher profit margin, it's just higher revenue. There's no minimums. There are no pre-orders, there are no door dashes or whatever you have called in, so the minimums need to be the zeros. Y and X are greater than or equal to 0. So we just had a conversation again. We need to make sure that, remember, the X values are my vertical lines with an undefined slope. It cuts through the X axis, and my Y values cut through the Y axis. All right, so I was able to, again, count this graph by 200s, okay? And again, labeling, is really important because those are points. Even if your graph's wrong, you get points. I went ahead and I did this line first. Since they're both counting by 200s, I could use my slope, or I can use my x and y intercepts of 0, 2500, 2500, 0. Okay, now that I've taken care of that line and both of them are less than, we're shading down. I looked at my vertical line, cut it right through here at 1000, and my other one at 0. Make sure that's shown even though it's an axis. I came back and did my horizontal line at 2000, shading below and greater than 0. Okay, so my shaded regions in here. Don't look at these and think they're all the same. If I told you they had to sell at least 2,500, then this would have been greater than or equal to, and we would have actually shaded this region. If I had to sell more than 25 overall things, it would be over here, and then the individuals would have capped me off. So please don't think that it's always going to look the same. It depends on the situation. All right, so now that we've got that, you are finishing this worksheet and you made sure you have 2 possible solutions with labels on them. Okay, so that's what I wanted to talk about on this to make sure we have the right answers. All right, so you have a problem for accuracy that is going to be turned in. I'm not showing you that one in case you got excited, but it is about this Mr. Stiles. It's set up very much the same. Define your variables, 5 equations for your inequalities. Remember, you're going to want to think about minimums. Okay, that's going to be some of your equations. I counted here by hundreds, so you can count by something else, but hundreds work for me. I don't think I'd show everything. I think I would show, hey, here's 100, 200, 300, 400, 500. But it's up to you how you want to do that. Make sure you label your graphs and give the 2 solutions with labels. So just a couple reminders for you. Okay, what I want to take some time and talk about now is what's on the back of this worksheet. So we're just going to go ahead and do this right here, right now in class or online here. So I'd like you to take a minute and notice that there are 2 inequalities graphed here. I have one labeled A that we're going to write here, one labeled B. And so we want to go back in that form of y equals mx plus b. But remember, we're going to replace the equals with an inequality sign. So all things we've done before, we just have to consider the shading. Okay, so the 2 things I need to write the equation of a line are m and b. So beside each line, find m, find b. Help yourself form those. We're going to put it in an equation and decide if it should be less than or greater than and equal to. Okay, so I was looking at this first one. The y-intercept is way down here at -2. Didn't leave myself enough room. My slope is dropping, so it should be a negative slope. I know these aren't the best copies. I am, well, that's a little bit rough right here. So I am going to try to find another nice point that it hits. Let me see here. It looks like I should be going down maybe 3, 1, 2, 3, and right here. I think that lines up. So this one we're going to have to just estimate. So you should have something close to -3 over 1 for your slope. If you're off a little bit, that's fine, but we should have a negative number. So we're going to take y and we're going to compare it to -3x minus 2. Okay, now with this, I need to decide where to shade. It's a solid line, and the shading is going this way, which means it's going up. Right here, it's going up the y-axis. So that would mean my y is greater than or equal to -3x minus 2. Okay, I can understand the slope being a little bit hard on this copy. All right, part B, my y-intercept is here at 4. So that's the quick, easy part. And it's a positive slope, and it's going up by 1. Again, you should have it going up. Maybe you picked 1 or 2, but the idea is it's a positive slope. So it's up 1x, and it starts at a positive 4. All right, this one is dashed, and it is shading going this direction, which again is going up the y-axis. So y is greater than, or oh, not equal to. Y is just greater than. Okay, so again, the best we can with reading these graphs. All right, on the next one, we have a vertical line here. We have a horizontal line for A. So let's start with that. The slope here is 0. All right, no rise, no run. Well, sorry, no rise and a run. And the y-intercept is at 1, 2, 3. So I am comparing y to 0x plus 3 or y to 3. So you could have it as 0x, but you can't have x. And then this is shading going down, so it is less than or equal to. So either is acceptable, but if you just have an x there, you're wrong because you're saying 1x. All right, B comes through at this angle. B has a y-intercept of 0. And then it has a slope that is dropping, and I'm looking right there that I'm going down 1. So my slope is down 1, and then over 1, 2, 3 units. I should have a slope of negative 1/3. Maybe you had it as 1/4 or 1/2. Again, I'll give a little bit of wiggle room there. Y is compared to negative 1/3 x plus 0, or just leave it like that. So you can have the plus 0 there. This one is shaded going greater, going above the line. And it's solid, so equal to. All right, our last one's a quick one because it's a vertical line. And if with my vertical line, my slope is undefined. And it cuts through the x-axis at positive 2. So we're comparing x in 2, and it's going to the left. So x is less than, and it's not equal to. All right, so I'm going to pause here and give you a minute to try the next set of inequalities. All right, last one for this. We have A as a horizontal line, and that is up at 8. So we are comparing y and 8. My slope is 0, my y-intercept is 8. So again, you could write it as 0x plus 8, and this is shading going down, so y is less than or equal to. B is one we have to think about. It has a y-intercept at 0. And it looks like I just go up 1 and over 1, so it's not too bad. The slope is 1. So we would be comparing y to 1x plus 0. And it, again, since the shading's up here, it's shading greater than the line, so greater than or equal to. Or maybe you just have y is greater than or equal to x, which is one of the inequalities that some of us had trouble shading with because we weren't picturing the 1 and the 0. All right, we've got two vertical lines. Slope is undefined again. It cuts through the x-axis at 1, and it's shading to the right, so it is greater than or equal to. And this one cuts through the x-axis at 4, so it is less than or equal to 4. All right, so wanted to go over that, taking and reversing our process. So for those of you that aren't here right now, depending on how class is running at the time you're watching this video, the next thing in your packet is our review. So remember, you're turning in this problem for accuracy as posted. This is your review, so it goes from 3-1, 3-2, 3-3. There's no back there. So it's definitely a shorter review. I will try to post a video of this and a key. The next review is what you're going to work on prior to your test. It is 4 pages, so we have plug it in, graph the system, and you have to graph it to get full credit, and classify it and give the solutions as an ordered pair, infinite, or no solution. We also have a back. Again, use substitution, solve and classify. And you have elimination method, solve and classify. You've got your word problems. You've got another word problem. Determine the number of solutions using slope. So I'll talk about that in a minute. You don't have to solve. You want to find y equals mx plus b and use our rules to compare slope. The back are your inequalities to graph. And you've got an inequality problem to do as a graph like you've been working on, and one that you are just going to set up. So those are your reviews. All right, last thing I want to go over. I quickly talked about the parts of here that you need to do. This is just plug it in. Does it work? Yes or no. Solve by graphing. And I want to talk about these problems on here, 4 and 5. And you also have similar problems on the other review. So if you go to the other review packet, these problems, 3-1, 3-3 review packet, where it says to determine the number of solutions and classify. Determine the number of solutions and classify, where you're not actually solving. So I want to go over real quick our rules. These rules are from our 3-1 lesson that we did. It's the back of the first page, so maybe go back to there, or maybe you made a note card. So there's three things that can happen with slope. So we want to talk about systems and what can happen very quickly here. And let me go ahead and do this in pen. Okay, so the first thing that can happen is I have lines that intersect. So how would I know that my lines intersect? I'll know they intersect because they have different slopes. So first thing I want to do when I want to do systems where I just want to know number of solutions and classify, but I'm not solving, I want to solve for y equals mx plus b, and I want to compare slopes. That's my goal. So I would see if they're intersecting, they're going to have different slopes, and that means when two lines intersect, they're going to have 1 point in common, and that's it. So when they have 1 point in common, they're going to have one solution. And if I don't need to solve it, that is enough information. But please note that if you're asked to solve it, you have to give the solution as an ordered pair. The classification is that it is consistent and independent. All right, so that's one thing that can happen. The next thing that can happen is that I have parallel lines, which I just spelled wrong. So that's the next thing that can happen, is that I have parallel lines. And if I have parallel lines, that means they have the same slope, but they have different y-intercepts. So my lines are going to be parallel, they'll never intersect, so I would have no solutions, and that classifies as inconsistent because it doesn't work. So again, this is just a quick review of how to do that. All right, and the last thing that can happen is that I have coinciding lines. If I have coinciding lines, that comes from having the same slope and same y-intercept. So basically they're the same line. If they're coinciding lines, they're going to overlap, and that means they would have infinite solutions. And if they have infinite solutions, it means it works, so it is consistent, but the lines are dependent on each other. So this would be great if you already had it on a note card to be using it. These are the three things that can happen. Whether I am talking about looking at graphs, this is what happens. If I'm just asking to find the number of solutions and classify without solving, it's a time saver. Solve everything for y equals mx plus b, and let's then compare what would happen. If you were using substitution or elimination method, I would get one solution because I got an x and a y. If I get no solutions, that comes from my x and y canceling and me getting something like 0 equals 10, which is not true. If I get infinite solutions, that comes from something like 10 equals 10, where my equations always balance. So this comes from a false statement, this comes from a always true balance statement, and this comes from getting an x equals and plugging in for y or vice versa. So that again should help you in problems with classifying and stating the number of solutions in your lesson quiz packet and in the other review that starts like that. Okay, I hope this helps you guys and hope to see you soon. Have a great rest of the day.